Not recording? Oh, no. Now we're recording. Glad you could all make it out here. This is obviously the we said early on in the group that we're going to rotate locations, and this is our first rotation of it. It seems like we have a pretty good crowd out here, so it looks like it's going to work pretty good. So. We would like to thank, a lot of effort went into rotating locations, and we certainly want to thank our friends at TeamSoft for the sponsorship, and obviously all sorts of good swag and provided the food and the drink tickets as well. So we really thank them. And if you haven't grabbed anything, please do. Also, our speakers tonight, he's around here somewhere. Yeah, back there, there he is, Tyler. And he's from Real Kinetic. Real Kinetic does have shirts here as well. Feel free, I think we got 4 different sizes there. Be sure to grab one of those before you leave as well. And I think we still have the stickers. We still have more stickers up there. If we run out, we still have more Cloud Data Madison stickers as well. So every month we take a survey. Last month we didn't take a survey. We'll be sure to send one out this month, especially with the change in location, to get everybody's feedback from that. And so I think what we'll probably do is we'll probably get it together tomorrow, and I think we'll add a link out to the Meetup site on meetup.com for that. So feel free to fill that out. Some other things. The next meetup, like I said, we're going to start this rotation. We are going to do a downtown location next time. I have about a 90%, 95% confirmation as of today that's going to be on July 10th. Obviously, we normally do it the first Thursday of the month, but that falls right around 4th of July. So we bumped it up a week, so that's Wednesday of the second week of July, downtown. I hesitate to say the actual location because we're 95% sure, but I think we're really close on that. So it's going to be right downtown. More on that. I'm sure we'll get that posted out in on the Meetup site in the next couple of days. We're still looking for speakers, but July we do have speakers. I believe both of the speakers are from American Family, and one is on Vault, and the other.
Yeah, so the first one is our journey to deploying Vault in production. Yeah. The second, I'm calling aspect-oriented deployments in Kubernetes.
Good. So yeah, so we have that going for us right now. So we do have also a speaker already lined up. One speaker for August. Still looking for one more for that. But we're actually doing pretty good with getting out ahead of the speakers, and they're all coming from the community right now. So that's really good. But obviously, if you have a talk or whatever, just see me or Brandon, and we'll get you on the schedule for the talk. News and notes. This week, Kubernetes turned 5. Woo! It's quite impressive, actually. I mean, this is really the basis around the Cloud Native Computing Foundation. It was started because of the donation of Kubernetes into it from Google. It's exciting. It's been 5 years. It really doesn't seem like 5 years. I mean, we started with containers about 5 years ago or so, and that space, that orchestration space, was a little shaky at that point in time. Within that 5 years, obviously Kubernetes really dominates that orchestration space at this point in time. Other things, Istio turned 117 at the end of May. They're also right now. I just saw a tweet from them that they're looking for community testing around 1.2. So it means 1.2 is coming out pretty good. And that's exciting as well. I mean, the service mesh on top of Kubernetes really adds a lot, to the to your functionality of your system or whatever. Really makes a far more robust platform. So it's really good to see that still maturing, and that's maturing at a pretty quick pace at this point.
Are they CNC up yet? Envoy is. Yeah, but Istio is.
Istio is CNC.
What are they doing?
They're still incubating, I believe, but
Oh, okay.
yeah.
Actually,
Yeah. And I believe this last week or 2 weeks ago or whatever, they started opening up the registration for KubeCon. Now, it's Cloud Native KubeCon together. If you've never been out there, it is really exciting. All the speakers and all the different talks on any topics that you can think of around the Cloud Native space. They sort of flip-flop. It's typically right around the time of reInvent, and typically I think reInvent's a week earlier than KubeCon, but I don't know if the late Thanksgiving got into place, but we're a little earlier this year, mid-late November. reInvent is beginning of December this year. Another thing that really excites me is Knative. Knative, if you're not aware, is the it's really how they're doing serverless, within within Kubernetes itself. So those sort of standard definitions. And I think a week or two ago, it turned 0.6. So it's getting closer and closer to that 1.0. Where it's going to be a lot more usable, or a lot more production ready at that point in time. I still haven't played around with it as much as I want to, but it's exciting to see that continue to grow. Obviously, that's a big space, and all of cloud computing is serverless type stuff. But another thing that really excites me is around the operator framework. I've always, to me, getting that operator framework where you can actually run some of those, those database technologies and stuff in there, right in the cluster, and have that managed, sort of the same way that you might manually manage it. And Couchbase, seems to be out ahead of this, and they went to 1.2 in their operator right now. Where I'm at right now at ARMS, we do not use Couchbase right now, but it is interesting, and hopefully, other database vendors follow suit. The one other thing I don't have on my points, but just wanted to mention that Brandon and I were lucky enough this week to actually meet with Google. Google started a program around customer empathy around the GKE space, and we got to go through a little working group, and actually give them a lot of feedback, on Kubernetes and maybe the pains that a customer might have with that, and sort of give some suggestions for the future. We did happen to get the opportunity to meet Kelsey Hightower during that. He led that group, which was really cool. But the reason I bring it up is, I know a lot of us have, different connections with different cloud providers. Google, seems to be, ahead, in some Kubernetes stuff, but they all have, their managed offering. If you have an opportunity, try to talk to your sales rep on that, and if you have an opportunity to talk to one of the vendors, they are really listening at this point around, getting your feedback, and it's really good for, to see that in the community as well, where, these large organizations are listening to the direction of that, even outside of the actual Kubernetes project. So, really cool. So tonight's speaker, as I already said, Tyler Treat. He is from Real Kinetic. They're a national consulting company that goes around and helps organizations maybe get better in certain spaces, or in this case, he's going to give us a little talk around the Observability Pipeline, and then go into a little bit of a demo as well. So since we are recording this, we are going to switch over. It's going to take about 2 minutes to switch over, but then he'll get going. He'll do it in 2 parts. We'll do the first part, and then we'll take a break like we normally do in the middle, and then we'll come back and finish it up at the end. So, no further ado.
All right. Go ahead and get started. So today we have sort of this theme of observability, and we're going to talk about what that means, how it relates to monitoring, and just kind of set the stage for the second half of the day, where we're going to do a demo, look at some of this stuff in practice, and kind of hopefully make it a little more concrete for you all. So how many of you have heard of this notion of pets versus cattle? Anybody? Yes, you do. So this is kind of a way to describe the shift in how we build systems. And in kind of this world of servers as pets, operations, and specifically monitoring for that kind of world, it's relatively uncomplicated. It's not to say that it's easy, but it's uncomplicated because we have just a handful of servers, or we have a single monolithic application. It's pretty easy to figure out the overall state of the system. And so tools like Nagios became popular. Various APM tools like Dynatrace, AppDynamics. These tools allowed us to get kind of visibility into the system, code level instrumentation, and our weapons of choice are things like just SSHing into the box and just poking around when something goes wrong, or grepping log files, things like that. And in this world, it's pretty straightforward to correlate system behavior with actual customer impact. You guys can't hear me? So it's pretty easy to figure out the correlation between system behavior and actual customer impact. Because when you have just a few servers, you have a single monolith. I lost my slides.
Yeah, I know.
All right, so we can correlate system behavior with customer impact. When we have a monolith and the monolith goes down, we know exactly how the customer is affected by that. And now in this new world of cattle, things start to change in pretty dramatic ways. Because now we have these container-based systems. We have Kubernetes, we have things like Fargate or Lambda, these serverless systems, where instances now spin up on demand and they spin down when that demand goes away. And so when you're debugging a problem, by the time you debug it, the container might already be gone. And what used to comprise a single monolithic system might now consist of dozens of different microservices. And so it becomes much more challenging to correlate the system behavior with how the customer is actually affected by that. Because when you have this mess of services, when one of those services misbehaves, or just one instance of a service misbehaves, it's much more difficult to figure out how that actually manifests itself to our customers. And so this shift in how we build systems has brought about all sorts of new technologies as well as new terminologies or new concepts. And one of these new ideas is this notion of observability. And really, observability, it's kind of a more nuanced take on traditional monitoring. So where monitoring is focused on kind of the overall health of systems and business metrics, observability is more about providing granular insight into the behavior of systems, as well as rich context that's useful not just for debugging, but also for other business purposes. And it's really this difference between post hoc and ad hoc. And if we think about kind of knowledge and meta-knowledge, we have the known knowns, right? The things that we're aware of and we understand. Right, the system has a 1 gigabyte memory limit. As the developers of this system, it's something that we're acutely aware of. Then we have the known unknowns. So the things that we're aware of, we don't necessarily understand. Right, the system exceeded its memory limit to crash, causing an outage. So these are things that they happen, and we learn from them, and now we know to look for these things going forward. We have unknown knowns, so the things that we understand, but we're not really aware of. And it sounds weird, but it's kind of like gut instinct or intuition that we have. And we implemented an orchestrator to ensure that the system is always running, because intuition tells us that when the process isn't running, then the service isn't available. So we want to make sure it's always running. So these are the things that we know them, we don't even consciously really recognize it. And then lastly, we have the unknown unknowns, right? The things that we're neither aware of nor understand. So instances churn because the orchestrator restarts the process when it approaches its memory limit, causing sporadic failures and slowdowns. So these are the things that we can't even predict or foresee happening, because if we could predict them, they wouldn't be unknown unknowns, they'd be the known unknowns. So these are things that they happen and we categorize them as known unknowns, and we know to look for them. And so the known knowns, these are facts. The known unknowns are kind of hypotheses. That's really what monitoring is about. The unknown knowns are assumptions, and the unknown unknowns are discoveries. And that's really the difference, I think, between observability and monitoring. Right? Monitoring is about hypotheses. Observability is about new discoveries. So it's testing hypotheses, which is what we do when we set up an alert. We monitor a resource, and it's exploring new discoveries, which is being able to ask questions of our systems on kind of an ad hoc basis. And so that encompasses a lot of different pieces of information, from distributed tracing to application logs, to system logs, events, and audit logs, and all these different pieces of telemetry. And there's some challenges involved in just dealing with all of that data. The first of which is that this data is often locked up inside a single vendor solution. Looking at centralized logging, for example, if you're using centralized logging, there's a good chance your logs are locked up in one of Splunk or Elastic or Sumo Logic or Graylog or any one of these logging solutions. And so that data is not always readily available across the entire organization. Or in some cases, it's too readily available if it's data that's sensitive in nature, and we want to limit the scope of who can access that data. And then also there's a lot of different tools and products that are needed for different data and different use cases. So the types of data that operations teams care about is different from the types of data that security folks care about. It's different from the types of data that product management cares about, etc. And so the tool and the data needs vary from team to team. But often we end up having to kind of standardize on a single set of solutions. We can't use the tools that are best suited to particular situations. And then there's just this ever-changing landscape of tools and products and services. Looking at cloud native CNCF, there's like 100 different new incubating CNCF tools. And it's just constantly changing. And looking at monitoring specifically, if you look at all the different monitoring vendors, they're all kind of converging on the same set of features between APM, logs, traces, metrics. They all are kind of converging on that base set of features. And so they try to differentiate in various ways. And so there's that constantly evolving landscape. And then lastly, just the sheer volume of data can be overwhelming between all of your logs, metrics, traces, etc. And so if we think about a hypothetical system, and we're sending our metrics maybe to Datadog and APM data, and maybe we're using Splunk for our logging, sending application events to like Google Analytics and maybe BigQuery for BI reasons, and sending our logs also to like Glacier for cold storage, like for audit purposes. And we might be using other tools as well. And at small scale, and especially in kind of a static environment, coupling our production systems to our operational systems isn't really that big of a deal. But at larger scales, and especially in these more dynamic types of environments, and in particular when we want to make changes to these different tools, it starts to become a little bit more of a problem. And how big of a lift is it for your organization to change some of these tools? And how easy is it to experiment with new ones? Is that a big lift or is it a small lift? Are you able to use the tools best suited to your particular use case? And so we have all of these different data sources, right, between VMs, containers, load balancers, VPC flow logs, and all these different data sinks, the places that may or may not care about all these different data sources. And so there's a question of what data do we send, but also how do we send it, or where do we send it, and how do we send it there? Because not all of these data sinks care about all these different sources of data. And so that's why I really recommend kind of a decoupled approach to this problem. And so that's where this idea of an observability pipeline fits in. It's a way to decouple these data sources from these data sinks. I'm going to talk about what I mean by this pipeline idea. And it's really not anything all that earth-shattering. In fact, a lot of you are probably using some of these patterns or ideas today already, but it's really kind of putting a common pattern over these different concepts. So I'll take a look at just what I'm talking about. How many of you are using structured logging? A few of you, looks like. So the first step to this, we've got to structure our data. And specifically, structuring our logs is a good place to start. Because we got to move away from the old way of logging, just logging strings, because regexing logs sucks. The last thing you want to be doing in a high pressure production incident is like grepping log files and regexing logs. And so we move away from that to this structured model where we actually have, it's really moving away from logs more towards structured events, because events are kind of like logs with more context. And that's going to be much more useful when we're debugging an issue in production. Because we can now take these events, we can index them, we can query them properly. And how you structure the data is not really that important. JSON is fine. But one piece of advice I have with this is to pass a context object to everything. So this is a pattern that it's kind of emerged out of Golang. It's, I think, one of the better patterns to come out of that language. And it's this idea that we pass this context object throughout our code as a request kind of traverses our system and even between services in our system. So the idea is we pass this context through our service, and we can set different pieces of information on this context and log it out as part of that structured logging. And so this becomes immensely valuable because we now have this really rich metadata as part of all of our logs as a request traverses our system. And to take it further, we can actually create a standard specification for how we shape that data, how we structure that data for our logs, for our metrics, for our traces, etc. And we can use that spec to even enforce certain fields on that data and data types of those fields. So for example, if we want to ensure there's like a user ID or a license ID on a request for each of our logs. And so that's helpful because now we can rely on certain pieces of information on being there when we're debugging an issue. But specs alone aren't enough. And we need libraries that implement these specs and make it easy for developers to actually instrument their systems. And the good news is for structured logging, there's already a ton of different libraries that do just that. You really just Google search your language of choice in structured logging, you'll find something. And for tracing and for metrics, there are vendor-neutral APIs like OpenTracing, OpenCensus, which we'll take a look at later. So next, we need some kind of agent that can collect all of this data from our infrastructure, from our hosts, from our containers, and so forth. And we need to be able to collect that data, perform transformations, perform filtering on it, and then write it to some sort of data pipeline. And so in the world of Kubernetes, this typically runs as a daemon set. And from the container side or from the application side, we commonly just write this data out into like standard out and standard error. So I recommend just using Fluentd, which is a cloud native project. There's also Logstash, which is a good option as well. And then that collector is sending this data to some sort of pipeline. So we need, between all of our log data, all of our metrics and our traces, events, and so forth, that's a lot of data. And so we need some kind of system that can handle that scale depending on our needs. So it needs to be reasonably scalable and fault tolerant. This is also what provides a buffer that decouples our producers from our consumers. So the good news is that there's a lot of options here already. Whether you use Kafka, or in Amazon you use Kinesis or Cloud PubSub in Google, there's a lot of different solutions that are available, both open source as well as managed offerings. And so we have this pipeline that we're sending our data to. Now we need to actually make use of that data. So we need some kind of component to consume it, perform some filtering on it, and write it to various backends. This is where that data spec also comes into play, because the shape of that data determines what we do with it. Right, we have data coming in from this pipeline. We're parsing the structure, the shape of that data. Maybe we're sending logs to Splunk and Glacier, sending traces to Stackdriver, sending metrics to New Relic, for example. And so it's primarily a stateless component, right? It's just reading data from that pipeline, looking at the shape of it, and it's writing it to different APIs. And so it's a pretty good fit for sort of these serverless solutions like Lambda or Cloud Functions. So we take all of these different ideas, we put them together, and this is kind of what our observability pipeline looks like. Right? We have our infrastructure between our VMs, our containers. We have this data collector, such as Fluentd. It's collecting all of our logs, our traces, our metrics, these different pieces of information. Writing all of it to this data pipeline, such as Amazon Kinesis, for instance. And then we have our data router, like a Lambda function, for example, just pulling that data, parsing the shape of it based on that spec, and then writing it to various APIs. And the thing to point out with this is we don't have to just build this whole thing out in one go. We can kind of iterate our way there. And there are some quick wins along the way as we sort of evolve to that model. And really, it's almost a set of best practices, I think. And so the first step to this is just adopting structured logging. It's something that's pretty easy to get started with and has a big payoff with it. Next is moving the log or data collection out of the process, because often what happens, and especially at larger scale, you can spend more time just writing your logs out than actually performing business logic. So the faster you can get that data out of the critical path, the better. And that's where Fluentd fits in, for example. Next, use a centralized logging system. Again, something I think that's pretty easy to get started with, whether you want to run Elk Stack, you want to use Splunk or Sumo Logic or some managed solution. There's both managed as well as open source solutions for that. And then we can introduce this streaming data solution. Once we have that data collector running, we can have that point to this pipeline or this streaming system, and then from there we can add various consumers of that data. And so with this kind of abstraction, it allows us to easily change some of these different systems, whether we want to change from Zipkin to Jaeger to Stackdriver for tracing, as well as evaluate multiple in parallel. If we're using Splunk for logging, but we want to try out Sumo or maybe Elasticsearch, we can just stand all of these systems up, just tee our log data to each of them, and just compare them. side by side. This is something I've seen play out at several companies where just dealing with Splunk licensing can become an issue, and so if you have this leverage to try out different solutions, it's going to make your life a lot easier. And so this idea of an observability pipeline, I think it's a way to really empower teams in terms of operating their systems and learning from their systems in production, because the reality is until you have an actual live thing running in production, you're kind of spending time learning the wrong stuff, right? You end up theorizing about those known unknowns and not learning from the unknown unknowns, the things that you don't really encounter until you're actually in production. And so this is a way to get that data back into the business in a very meaningful way, in a way that allows us to use the right tools for the right situation, because we've decoupled our system, our production systems, from our operational systems. There's a lot of power that comes with that. And so that's the observability pipeline. I think we're going to take a short break, and when we come back, I'm going to do a demo. We'll look at some of this stuff like in practice, what that actually looks like, hopefully solidify some of these ideas. All right, so we got kind of our microphone situation set up here. Hopefully you can hear me a little bit better. So in the second part of this session, we're going to do a demo and hopefully just make some of these ideas that we talked through in the first half a little more concrete for you. And it's kind of a whirlwind of stuff, so we'll go a little quick, but I'll try to make an effort to make sure we're kind of walking through each idea. So this is the application that we're going to be using for our demo, and it's kind of this travel agent application. So we have 4 different microservices. We have this trip service. It's backed by a flight, hotel, and car rental service. And each of these services is using Dynamo to store some state. So the first thing I want to take a look at is this idea of structured logging we talked about in the first session, and also this idea of context object. So I'm going to take a look and open up code for the trip service. Hopefully I can make this readable for you all in the back. How's that? Good. So the code, a lot of the code we're going to be looking at is Golang. If you're not familiar with Go, don't worry. If you can read like Java, C, Python, JavaScript, you should be able to kind of follow along with what's going on, and I'll talk through what's happening. So don't worry too much about the syntax, and I'll kind of focus on a few different pieces of this code. So this is the entry point for that trip service that I just showed, and basically what it's doing is we're setting up an HTTP handler, and it's very, very rudimentary. We're just setting up a single endpoint, this trip/booking endpoint. We're binding this booking handler function to that endpoint. That's what this is doing. And if we take a look at the booking handler, it's just kind of a rudimentary, it's doing this select on the HTTP method. If it's a GET request, we're just going to fetch the booking. If it's a POST, we're going to create a new trip booking. And if it's neither of those, then we're going to return back an error to the client. And so the first thing I want to point out with this is you can see that we're pulling this context object off of the request. So this is actually part of the Go standard library, and that there's a context associated with an HTTP request. The languages that don't support this is like a first-class thing. This is commonly implemented through like a middleware. And so we pull this context off of our request, and you can see that we're passing it through just into different function calls. And we're also logging it out as part of our structured logging. There's an example of that happening right here, where in this case I'm just including the error that we're returning back to the client. And if we take a look at book trip, for example, you can see that the first argument to this is that context object. pass in the response writer, which is how we write back the HTTP response, take in the request. And you'll see that I'm pulling this ref, which is the booking reference, off of the query string on the request. And we actually set that on the context here, which is what this util with ref is doing, is it's just setting that reference value onto that context object, and we pass that context through into our service code, which is kind of the back-end implementation, which is actually, in this case, fetching a booking confirmation. It's passing the context and that booking reference number. And just to give you kind of an idea of structured logging, so this is the book trip function. Basically what we do here is we deserialize, right here, we deserialize the request from JSON into a booking request object. We validate that request, which is just doing some business logic. And we call book trip, which is actually doing the booking. That gives us back a confirmation if everything goes smoothly. And again, I'm setting that reference on the context object, which is what this does. And then we just marshal it and we write that response back. But to give you an idea of structured logging, basically we're doing this with context. And I can add fields to my logging, so I can do with fields, and I can add some useful information that is helpful in debugging, for example. We'll see what this logging actually looks like in just a minute. So I'll just add a couple fields to my log, and now I'm going to go ahead and run these services. So I'm going to start the trip service. I'm going to start the flight service, the hotel service, as well as the car rental service. And I'm just going to hit the API endpoint that we looked at using Postman to make an HTTP request to that endpoint. It's probably not readable for you. Maybe I can make it bigger. And the contents of the request aren't really important for this demo, but basically I just have some information about my trip, like the flight info, the hotel, the car, and I'm going to make a post request to that endpoint. Get back 201 created response, has the booking reference on it, and if we hop back to our output of the trip service, we see some JSON, and I'm going to take one of these logs and just pretty print this so we can see kind of what this actually looks like. And it might be a little small, but you'll see we have this context as part of our structured log. Context has IP address for the caller, has the HTTP method on it, has the URL path, query string, that booking reference we saw, as well as this request ID. And then we also have those fields that I added to that log statement, as well as some other information like the host name, the log level, log message, etc. So we get some pretty rich metadata as part of our logs, and we can start to add some really useful information to this that can help us as we're debugging in the future. So that's structured logging, and now I want to show this application running. I have it actually out in Kubernetes right now. I have a cluster on EKS. It's for you, Jerry. And I got it running out there, and so it's Kubernetes. So now we're going to look at a bunch of YAML, since that's what Kubernetes is. I'm just kidding. We are going to just take a peek at some of this config, just to give you an idea. So we'll take a peek at the config we have for this trip service, and it's really not that interesting, so we won't spend a lot of time, but two things to point out is we have this deployment, which is just deploying our trip service container. And we also have this load balancer service, since that trip service is kind of the entry point into this system. It's sort of the front end to it. So as I said, I got that running out in Kubernetes already. And just to show you that, so you can see when I get the pods, we've got the car service running, the flight service, the hotel service. I also have Jaeger currently running, which we'll take a look at in a little bit, as well as the trip service, and then the Zipkin GCP thing, which we'll talk about in a little bit. So that is currently running, and now I want to hit that API that's deployed out there. I got my ingress set up on that, so I'll hop back over to Postman just to make a request to that API. So I'll make a new booking. That returns a 201, and I can take the booking reference from the response, and I can fetch that booking. And you'll see that this API kind of takes a few seconds to return that response back. So the performance on this service isn't too great. And the problem is, our architecture looks something like this, right? We have these different services, and so that source of slowness could really be any combination of these things. And that's where tracing fits in, as it gives us some visibility into what's kind of going on throughout the life cycle of a request as it goes through our system. And OpenTracing in particular, it's a cloud-native project which basically implements a vendor-neutral tracing API. And so I already instrumented the application using OpenTracing. And take a look at the trip service code again. And if you noticed, in this main function, I call this init function, which is this utility package that I wrote. And what this is doing is doing a couple things. So it's first initializing our logging and our tracing. So specifically, what it's doing for logging is we're setting it to use JSON logging. So we're structuring our data with JSON as JSON, and we're just logging that out to standard out. That's pretty much all we're doing there. And then for the tracing part, I call init tracer, which is this function I wrote that is going to create an instance of an OpenTracing tracer object. So OpenTracing provides this vendor-neutral API. In this case, I'm actually using the Jaeger client library to create an instance of my tracer. It's really, in this case, irrespective of the backend that we're using for tracing. It's just one implementation of OpenTracing. But I'm creating a new tracer. In this case, I'm configuring it to sample every request. So 100% of the spans are going to get sampled. And we're just going to send all of our traces to our logger. So that's going to get logged out to standard out as JSON. This is how we configure our logger. So that's how we're configuring our logging and our tracing. And the way that we actually instrument our application is largely through middleware. So it's going to happen, for the most part, instrument our application kind of transparently to our code. And I'll show an example of how that works. So we have our booking endpoint, booking handler, and the way that we're instrumenting our HTTP server is we're creating this new context handler. And the default serve mux is just the way that I bind my HTTP handler function to that HTTP server. But then I'm wrapping that with this context handler. And so if we take a look at that, what this is doing is it's creating an HTTP handler that implements tracing as well as this context middleware. So we have a request that comes into our HTTP server. We want to make sure we create a span for that, and I'll take a look, when we look at Jaeger, we'll look at what a span actually is and what it looks like. We create a span for that request, which is what this net HTTP middleware is doing. It's actually an OpenTracing library. So we're passing in our tracer to that. We pass in that handler, that serve default serve mux, which has my handler function on it. And then we're setting the operation name, which is like the name that we're putting on that span. In this case, we're just going to use the HTTP method and the URL path of the request. So that's how we instrument the tracing. And then I wrap that in this context middleware. And what this is doing is basically every HTTP request calls this serve HTTP function. And what I'm doing here is when a request comes in, I want to take a look at the headers on that request. And if there's any context headers on it, I'm going to take those headers and then put them on that context object that we looked at. So that's how we're propagating those context values over the wire, is they get set as HTTP headers. We take that and just pop those onto that context object, which is what this context with request does. So it constructs a new context with those header values set on the context, and then we just set that new context on the request and pass that request in to our HTTP handler. Does that make sense at all?
Yeah.
Maybe. Hopefully it'll click in just a little bit. Okay, so that's how we instrument the kind of incoming side of requests, right? So we have requests coming into our service. They're getting traced. We're propagating the context values from that request onto our context object. But then we also we're integrating with Dynamo to store data. We're also making calls to those other services that we looked at, like the flight and the hotel service via HTTP. So we also want to instrument that stuff as well. And you can take a look at the code for that in trip service, this is kind of the back end portion of this service. We looked at the HTTP server side. That calls into this back end component. And so what we have in here is the piece that we care about is this trip service interface, which just has two functions on it. It has the book trip call and the get booking call. Both of those take that context object, and then book trip takes the request, and get booking just takes that booking reference. And so that's the interface. The implementation of that interface is this Dynamo service struct. This has a couple items on it. It has a DynamoDB client, which is what we use to talk to Dynamo. And then it has this HTTP client. That's what we use to make REST calls to those other microservices. So these are the two things that we want to instrument. And the way that we instrument Dynamo is, it's actually pretty simple. We just call this add OT handlers, which again it's like an OpenTracing library for Dynamo or for AWS SDK. We just pass in that Dynamo client, and it automatically injects the tracing middleware so that every request we make to Dynamo, it's going to create a new child span within that context. So that's how we instrument Dynamo, and then the way we instrument the HTTP client is I have this utility function called new instrumented HTTP client. And what this does is it creates an HTTP client that's instrumented both for tracing as well as for propagating that context. So we saw that on the server side. Now we're making calls out. We want to do kind of the inverse of that. And the way we do that is we create this round tripper, which is what the standard library, the HTTP client, uses a round tripper interface, which just allows us to add some logic around outbound HTTP requests. So every HTTP request we make basically calls this round trip function. And what this is doing is, for that request that we make, we're going to add those context headers. So we're going to take our context object, We're going to pop the values off of that. We're going to add those as headers on that request that we're making so that those get propagated. Then on the server side, we saw that earlier, it's taking those headers, putting them back on the context. And then we're going to trace the request. Again, this is just using OpenTracing. So we call trace request. We pass in our tracer as well as the request that we're tracing, setting the operation name again, and then we just make our request, and defer finish just closes that span. So that's a lot of stuff, but we'll look at Jaeger in a little bit, which shows how we actually make use of all of that instrumentation. Hopefully that will make more sense. Okay. So we have our application, it's instrumented, it's running, and if you saw, when I got the stuff that I have running in Kubernetes, I already have Jaeger running. It's already exposed, so I can hop over to the Jaeger UI. So this is the Jaeger UI, and you'll notice that we don't actually have, make that bigger, we don't actually have any traces in here, despite the fact that our application's emitting tracing information, it's running, we've made requests to it, and the reason is we're not actually doing anything with that data that we're emitting from our services. And just to prove that we are like emitting tracing data, I can take a look at like the logs from one of these services. So I'll take a look at the log output or standard out from like the car service I have running. And we get a whole bunch of JSON stuff. You'll also see there's a bunch of like base 64 stuff, and those are actually our traces, our spans. We're base 64 encoding those, and we're just including those as part of our structured logs. So our service is emitting stuff, but there's nothing that's actually like collecting that data. And so that's where Fluentd fits in. As a data collector, it can take all of that output from those different services that are running and just send it to different places. And so in this case, we're going to send that data to Kinesis, which is a streaming data system in AWS. So that's kind of what our system looks like once we deploy Fluentd. So I'm going to take a quick peek at the config we have for Fluentd. The things to point out with this are just a couple things. So we're running Fluentd as a daemon set, which means we're going to run an instance on each node we have in Kubernetes. In this case, I just have 2 nodes running. And we are actually using the Kinesis plugin for Fluentd. And so we can configure Fluentd to just point to a Kinesis stream. So the config that we care about really is the stream region, which is the AWS region. In this case, I'm using US East 1. And then the stream name, which is the Kinesis stream that we want to send this data to, which is Observability Pipeline. So I'm going to go ahead and deploy Fluentd. And that is running now, and just to double check. We can see there's two Fluentd pods we have running, since there's 2 nodes running as a daemon set. So that's out there running, should be collecting that data and sending it to Kinesis. And now, we need something that can actually consume Kinesis, right? Which is this stream of data we have. And so we're going to set up a Lambda function to read the Kinesis stream and process all of that data. And so I already wrote a Lambda function to do this. In this case, it's Python, and I'll just walk through what this code is doing. It's fairly simple. So this is our Lambda function, and so this is getting invoked every time Lambda gets like a batch of records from Kinesis. And so we're just going to iterate through each of those records. We're going to base64 decode, since they're all encoded. And then we just call process record on each one. And what process record is doing is, and this is where that spec that I talked about can fit in, is it allows us to process this data in different ways depending on the shape of that data. In this case, I'm doing kind of a rudimentary processing of this data. So I'm just doing a JSON decode of the data. I'm pulling out this log value, which is that structured log that my applications are emitting. And since it's JSON, I'm doing a JSON decode of that, which gets me this dictionary. And then I'm just doing this pretty rudimentary check. I'm checking if there's a trace in the log that indicates it's a span that I instrumented. Otherwise, we just call process log. So if it's a trace, we call process trace on it. And what this is doing is it's decoding that trace, since we saw it was base64. And then it's sending it to a couple backends. So it's sending it to Jaeger as well as Google Stackdriver. So we're sending traces to 2 different collectors. And then for process log, we're also sending our logs to 2 different backends. So we're sending our logs to Stackdriver as well. And then we just print them out, which effectively is going to send them to CloudWatch and AWS. So we got our Lambda function. This is sort of what that looks like. It's feeding in from Kinesis. In this case, it's actually sending data to CloudWatch, to Jaeger, and to Stackdriver. So we have all of this wired up now. So if I make some requests to our service again, this time those should be feeding in to Jaeger if I did this right. So I'll just make a post request. Again, we don't really care about what the request is doing, but I'll make a new booking, and then I'm going to make some GET requests just to get some tracing going. And if you recall, the reason we're doing all this is to try to figure out why my service is so slow. So I'll make a few requests to that. And really within a matter of seconds, if this is actually working, we should see these load into Jaeger, and it looks like we do. So if I just do a search for the last 20 traces, you can see my post request. That's readable, folks. See the post request and those GET requests that I made. So now we can actually see what is the value of all of this, because what Jaeger does, and it's kind of hard to read because I have to zoom in, but it gives us this nice timeline of the life cycle of a request. And so we can see each point as a request goes through the system, what's going on, how long it takes. We can also get logs for a particular span. And so we get some really nice visibility into what's going on. We also have this timeline view, or this graph view, which is not going to be readable, but we kind of see that if I can zoom in enough, we can see what this actually looks like, right? So we have my trip service. It's making a call to Dynamo to put, when I create a booking, it's putting an item in Dynamo, and then it's calling those back-end microservices, the flights, the hotels, the cars APIs. Those in turn are also putting an item in Dynamo as well. And to track down the source of the slowness, we take a look at one of these GET requests. This one took 5 seconds. We quickly see there's a couple issues that are wrong. One is we have kind of this waterfall effect where we're making a request to the flight service. After that finishes, we make a request to the hotel service. And then after that finishes, we make a request to the car rental service. So one thing we can do is just make those in parallel rather than doing them serially. But the bigger source of slowness is, if you can see, this call to the hotel service, specifically this validate hotel reservation call is taking like 4 seconds. And I actually have like some logs, so I'm setting some metadata on here, which is kind of nice. I have the hotel name and the reservation name and the booking reference number, so we get some really nice visibility into what this request is doing. And if I hop back and take a look at the code for that hotel service, this is where that validate call is happening. And so in this case, I'm actually manually creating a span. We saw that a lot of this instrumentation just happens through that middleware, so it's kind of transparent, but we can also, if we want to trace like a part of our application, we can create a span ourselves. So I call this start span from context, pass in that context object. That allows us to associate this new span with the parent span. I give it a name, I'm setting some logs on it, and then I make the call to the thing that I'm tracing, and then I call finish, which just closes the span. And so if you take a look at validate, it is it's doing a sleep. So as any good engineer, I'll fix that by just making the sleep 0, actually 1 second, I think. But we can fix it later, and then people will be happy with the performance. And this is another example of structured logging I have. So you can see like setting the hotel, check in, check out, just different pieces of metadata that, if I'm debugging a request, for example, having that is pretty helpful. So that's Jaeger. I mentioned that we're also sending our traces to Google Stackdriver, just to make Jerry happy. We'll take a look at that. So this is Stackdriver, and if I reload, we should see our traces showing up in here. And in fact, we do see our GET request, and that is it was just zoomed in, so I couldn't actually read the text. But so Stackdriver gives us a very similar timeline view to what Jaeger gives us. We have the same metadata for each of our spans, and so we have our traces in 2 different places. And we're also sending our logs to Stackdriver, so just to show you that, so we're feeding our AWS logs into Google Stackdriver, and you can see that we have our structured logs are here. And I can show you, hopefully kind of highlight the value of structured logging, because Stackdriver is actually taking that JSON, it's parsing it, and just to give you an idea, if I expand this context on this particular log, I can take the request ID from this log, and I can actually filter my logs using that request ID, and then get back all of the logs that are associated with that particular request. We've correlated our logs, and so we can get a nice kind of timeline view of our logs for a single request, and that's pretty helpful. And just to prove that we also have logs in CloudWatch, take a look at that. And it's not really that interesting, but we do have our JSON logs in CloudWatch as well. So that's a whirlwind of stuff, but hopefully this shows not just the value of structured logging and that context idea, as well as tracing, but hopefully it also shows the value of this pipeline idea of kind of decoupling our production systems from our operational systems, and having that abstraction that allows us to send this data to different places to make use of it. And that kind of wraps up the demo. If you want to take a look at the code for this, it is up on GitHub, and I'll post the slides so you can access that. And that's it. If that's helpful.
So as a relatively new tool set, what do you think about how mature OpenTracing is at this point? Are there any kind of rough edges? And do you know anything about what we can expect from the merger of OpenTracing and OpenCensus?
Yeah. So the question was basically like how mature is OpenTracing, and now that OpenTracing is actually merging with OpenCensus, what does kind of that landscape look like? And OpenTracing is pretty nice. It depends like what integrations you have. So in this case, I'm using AWS, their SDK, which has a pretty good library to instrument. GCP has one as well, and other integrations. So if you have an integration, it's really nice. It makes it easy. If you don't, there's more boilerplate you're gonna have to write. But it's a pretty stable library, I think. And I don't really know what their plans are with the merger, because I know they just announced OpenTelemetry, which is like the new combination of those two things. And I don't really know what the roadmap is for that, so I don't have a good answer. Sure. But basically, if you're not familiar with OpenCensus, it's another observability library similar to OpenTracing, but it also has like metrics and other things. And so people recognize that these two libraries are kind of competing, and so they've decided to merge those into a new project called, I think it's called OpenTelemetry, something like that. But I'm not sure what the roadmap looks like. Yep, in the back.
So, what's your thoughts? We have used Sleuth, Zipkin, and like newer Spring Boot application, and it works fine. What's your thought on like the old monolithic application where we still have them, but we need to put more instrumentation? Is there, because it requires certain amount of architectural like separation, right? We cannot open 70,000 Java classes and start putting different types of like instrumentation or like aspect oriented instead.
Yeah, so you're kind of talking about maybe instrumenting like a legacy system or an existing system, and like how do you go about instrumenting it? I think Aspect J is probably one option if you can implement just an aspect that wraps all of your stuff. There are other tools available that can actually take like unstructured data and add structure to it, which might not help with tracing, but if you have like logs that are emitted in a weird format, you can make better use of that data. So Cribble is one. I think it's Cribble.io. It's kind of a neat product. It's kind of like the data router component of that pipeline that I showed, where you can feed in data from different services like syslog or firewall logs or legacy systems, Nginx or what have you. You can actually program it to structure that data, even redact pieces of information if you have like PII in that data, and then send it to different syncs like Kafka or Kinesis, etc. So that's a nice solution if you have like legacy unstructured logs. On the tracing side, I think Aspect J is probably a good option. I don't really have, I guess, a better answer for the tracing stuff, but yeah. Does that answer your question?
Yeah, it does. I just wondering if anybody has any experience.
Yeah, by all means, if anybody has ideas, you can open it for discussion. Yeah.
Is your example online at all?
Like the code.
GitHub or something? Yeah.
Yeah, so the code had a link open, which is gone now, but it is up on GitHub, and I'll post the slides as well, and the code is on GitHub.
We'll get it up on the Meetup page.
Yeah, perfect. Yep.
So should it be a team policy that the context, the first person, the trip API decides what the context looks like, and then it should be read-only going down through the layers.
So the way context works in Go specifically is it's actually immutable. And so when you add a new field onto it, it creates a new context with that field, and then you take that and pass it along. So you could use that immutability pattern in really any language. You might just have to do a little more work if the language doesn't have that same thing built into the standard library. But the same idea, I think, would work.
Yeah, and that's the part kind of tripped me in a sense that the legacy, or when I'm saying legacy, it's a Java application, monolithic, but you cannot open Observability class files and start and discard it, so that's why.
Why not?
Yeah.
So, adding back to this question, when a customer allows stuff, what about the PII doing? Like the first person, third time?
I have a bunch of
What about
noise
PII?
coming. What about PII?
On the context.
That's a good question, and it definitely comes into play when dealing with logging. You know, if you have PII, like a social security number on a context, and you log that context out. There's tools that can help, like Cribble. The best answer though is code reviews. Really, it's your best line of defense. What's that?
Data masking?
I,
Data masking?
Oh, data. Yeah. So with data masking, there's Cribble can do that. If you want to introduce a system that can like filter your logs and clean that up, I think really though your best line of defense is code reviews to make sure that like PII isn't leaking into logs, whether you mask that yourself or you don't include it or some other policy. I think that's really your best bet.
Any other questions for Tyler? All right, let's give him another hand.